them for the problems we didn't get done in class on compositions of functions. And so the directions say find g of f of x, which it also can be written like this, and f of g of x. And all that means is if you treat it just like you did, if you were finding g of 2, you would plug in 2 for x. We're finding g of f, we plug all of the f of x in for x. So g of f of x would be the same as g of 3x squared, because that's what f of x is. So if you plug in 3x squared there, you get 3x squared plus 6. And then f of g, the other way around, would be taking g of x and plugging it in for x in the f of x. So f of g would, and you can just write it like that when you're working them out, f of g would be 3 times x plus 6 squared. And so you can multiply that all the way out, simplify it, but it means the same thing. So x squared plus 12x plus 36. So 3x squared plus 36x plus 108 would be f of g. Let's go down to number 5. G of f would be -2, and sometimes I'll just leave a parentheses where the x was and fill in our f of x there. And simplify. And f of g would mean you're taking this and plugging it in for x, so we'd have -2x squared plus 3 times -2x plus 2. Note the parentheses. They are important to make sure you get things right when you multiply here. If you don't put parentheses around it, you might make this -4x squared. It's 4x squared and -6x and 2. And we'll talk later about what g of f and f of g, if they're equal to each other, what that can mean. So again, g of f on this problem would be the same as g of 3x squared plus 1. And f of g would be the same as 3 times x minus 2 squared plus 1. You can always just, if you use parentheses, you can always see the shell. And then it's just algebraic simplification. On the back, we have 3 functions that we're doing, and sometimes there's some numbers. So something that can make it a little bit easier, f of g of 1, you can write the whole f of g of x out, or you can say, I'm going to find g of 1. So g of 1 would, if I plug 1 in here, I get 5. So I'm really just finding f of 5. And that would be 5 squared, which is 25. G of f of -2. Some people get confused and say that means multiply, but it's substituting. The other way you could write that is g of f of -2. It's just a different notation. So I'm going to find f of -2, which is 4. So I'm really finding g of 4, which would be 20. 5 times 4 is 20. H of f of 4, again, find f of 4, which would be 4 squared, 16, and plug that 16 in for h. So h of 16 would be 20. So similar there. A couple unusual ones. F of 4. Again, it could be written like this. You might see it's the same question. So don't get confused. You're not squaring something. Find f of 4. If you go up to f of 4 is 16. So I'm really just finding f of 16. Plug 16 in now and get 16 squared, which would be 256. And then we get to the really good ones where you f of h of g of -1. So just work your way from the outside in. I would do it like this, f of h of, and find your g of negative 1. So g of negative 1 would be negative 5. And then we're going to have f of whatever h of negative 5 is. If you plug negative 5 in here, negative 5 plus 4 is negative 1. So really this problem is just f of negative 1. And f is x squared, so negative 1 squared is 1. F of g of h of 4 could be written like this. Work your way from the inside to the out. So h of 4 would be 8. So I'm finding f of g of 8. G of 8. 8 times 5 is 40, so it's f of 40. Well, f of 40 would be 40 squared, or 1600. So those are compositions of functions. I'm not going to go through the challenge one that says work backwards. But you can see that you're going to build your own composition that ends up giving you 4x squared minus 9. So some kind of composition that when you plug it in, you get 4x squared minus 9. When you plug in g in for f, so I need a g of x that when I plug it in for f of x, I get 4x squared minus 9. So that should take care of the composition notes that if you didn't get a cover, we're hopefully going to cover some of these, but I know we have a shortened period. That helps you cover the rest of those.